We're recording. So, so we've talked a little bit about linear relations, and recently we've been talking about functions, right, and the rules of functions. And linear relations are pretty much always going to be functions. Um, but a linear relation is literally just a set of points on a graph that form a straight line, right? That's literally what they are. So if I had points on a graph, they'd follow like a particular slope. And when we connected them together, they would form a straight line, right? And that's really what a linear relation is. And these graphs, right, can be expressed as equations. Like anytime we have a set of points that follow a certain pattern, have a certain relation, we can express them as an equation. And the standard form of that equation, that's not how you spell standard. I'm like adding letters. The standard form of an equation is ax plus by equals c. And it does have a rule, and that is that a has to be greater than or equal to 1. Right? So we can't have a negative number in a, and we can't have 0 as our a, or it'll mess up our equation. Now, why we teach you the standard form of an equation, I don't know. I think it's a stupid form to use. We tend to more often use slope intercept form, right? So what we're going to talk a little bit about is converting from standard form to slope intercept form. First, we're going to talk about putting equations into standard form, and then we'll talk about putting them into the useful form, which is slope intercept. And then we'll just talk about how to graph from slope intercept, because that's really where our lesson lies. We've talked a lot already about perpendicular and parallel lines and the difference, but I'll do a quick review of it for you. And then go into intercepts, which we've also done, but now we're just talking about graphing from those, right? So if I have an equation, say negative 5x plus 6y equals negative 12, it looks like that's kind of in standard form, but it doesn't follow that rule, right? It's got a negative on that x. And so if we wanted to put this, if we were being asked to write this in standard form, we would have to handle that negative, right? And the way we would handle it, anytime that's your only problem, is that you need to change a sign on something. If you multiply everything by negative 1, it changes the signs of everything, right? So I would just multiply this times negative 1, and I would have 5x. But I would have to multiply each piece. So minus 6y equals positive 12. And now it's in that standard form of an equation, and that was a really easy fix for us, right? It won't always be that easy of a fix, though. Sometimes we'll have stuff like y equals 2x minus 9. Now, in my personal opinion, I don't know why we'd ever want to change it from this form, right? Because this is our slope intercept form and it's super useful. But if we were being told we had to put it in standard form, right? What we know is we're going to want to move this 2x over. We'd want to subtract 2x from both sides. And then I'd be left with minus 2x plus y equals negative 9. And the issue with this is, yes, we have it in that x plus y form, but we have that negative on the 2. So again, just like the last time, we would have to go through and multiply the entire thing times a -1 to change the sign on that, right? Here we get 2x minus y equals positive 9. And then it's in that form. And there's going to be all sorts of different kinds of problems that are going to require you to change things up. This one I like a lot. I'm only going to show it to you because it's kind of a fun one when you think about it, because it looks awful. And then you go, oh, that's not so bad. If I have 3/4 x minus 1/3 y equals 1. This is kind of in standard form, but except for we can't have that 3/4 x there, right? It's not greater than or equal to 1. So if I had a problem like this, I would get rid of the fractions altogether. And here I have a 3, and here I have a 4. If I multiply this whole thing times 3 times 4, which is 12, right? Well, 12 divided by 4 is 3, and 3 times 3 is 9. This would give me 9x. 12 divided by 3 is 4, so this would be minus 4y equals 12 times 1, which is just 12. And I got rid of all of my fractions. And is it in standard form now? Oh, yes, maybe. Yeah. Yeah. So I told you all of that, and we did some examples as to how to get this into standard form. But ultimately, standard form sucks. It's super not useful, right? I just said that on video, so don't show your mom. The form that we found most useful, and we've gone over it before, is that slope intercept form. Your mom would probably agree. She's probably a smart woman. Slope intercept form, the reason we like this form is because it's useful. Like, we could easily graph anything from slope intercept form. And you guys know it as the y equals mx plus b, right? And why it's useful is because it gives us a point on the graph. This b is our slope, not stope. It's our slope. Is our slope intercept, right? Our y. I don't even know why I'm calling it a slope intercept. It's not a slope intercept. It's our y intercept. What that means is it is our point on the y-axis, y-intercept. And then from that point, we can use our slope to find our next point, right? And that's why I find it to be the most useful of all of our, equations. I was like drying out. Now, when we're talking about slopes, there are 4 different kinds of slopes, right? We have, here, I'm going to draw like 4 graphs really quick so that you can see. So I can make the graph a little different. We got positive, negative, 0, and undefined. And we've talked about this when we were, if you remember, when we were writing equations from 2 points and we were finding slopes, we talked about 0 and undefined, but we really didn't talk a lot about positive and negative. A positive slope is just a slope that's increasing from left to right, right? The slant is going upwards as we look at it from left to right. A negative slope is the opposite of that, right? It's going down from left to right. Right? It's going in the negative direction. The zero slope, if you remember correctly, is one where it was just a horizontal line. And it usually shows up in an equation that comes out as y equals, and there's no like x value. So you'd have something like y equals, we could call that 3. And an undefined slope is a vertical line, straight up and down. And that would look like something that's like x equals some number when you rounded it all out, right? You wouldn't have your y value would have dropped out. So those are your different slopes. Another thing is, since we're talking about functions, if I have a y equals mx plus b, I could also see that as an f of x equals mx plus b. And when that happens, just consider that f of x to be your y, right? Those are kind of interchangeable when we're talking about functions. So if you see it written in the form f of x equals, and then you have the equation and it's in slope-intercept form, just change that f of x to a y, and you should be able to solve it pretty good. But like I said, this is more today about the graphing of stuff. And so we are going to take equations, and sometimes they're going to be written in the standard form, and sometimes they're going to be written in the slope-intercept form. You're going to want to change them to the slope-intercept form in order to graph them. So if I have, oops, I hate it when it does that. If I have, for example, the equations 10x plus 5y equals 5, and negative x. Oh my gosh, I don't even know what I'm doing. I'm like jumping to the whole wrong section. Dude, I'm losing my mind. It's been a long day. If I have y equals 2/5 x plus 7, and I'm asked to write it in slope-intercept form and then graph it. Now, this one's already in slope-intercept form, so we really don't need to change the form. Graphing it is going to come fairly easy when it's already in slope-intercept form, right? I'm going to make a graph. Let's go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 9. Do they have descriptions? Right? Just, you're lucky your worksheet will already have the graph. You just need to plug it in. So there's things I know when I look at this graph. And the first thing that I know when I look at this equation is that I have a point on the y-axis, right, at 7. 1, 2, 3, 4, 5, 6, 7. Right? Because that's my y-intercept, right? It means I know I have a point there. My slope is 2/5, right? My slope equals 2/5. That means I have my rise on top, which is plus 2. And I have my run, which is 5 in the positive direction, so plus 5. So from here, I can either go up 2 and positive 5, or if I want, say I don't have a lot of room to go all the way up, a positive slope is also a negative over a negative. So if I chose to go down 2 and then negative 5, that's still positive slope because a negative over a negative equals a positive. So if I wanted to, I could go down 2 and over 5 in this direction, and it would still work, right? If I connected all of these points. Okay, well, if I drew it better and I connected all of these points, I would have a line right through there. All you need for the equation of a line is 2 points, right? To graph the equation of a line, you just need 2 points. So if I have a point on that y-axis and I know what my slope is, I can always find my next point. Does that make sense? Like if you have one point and you know the slope, you can always find that next point just by counting out your slope. So let's look at another example. Let's look at, I don't want to go up too far because I want you guys to be able to see it. So if I have x plus 3y equals negative 15, and we want to write this into slope intercept form and then graph it. First thing I want to do is I want to move that x over, right? So I'm going to go minus x, and I get 3y equals minus x minus 15. I'm not there yet because I still have that 3 being multiplied to the y, so we're going to divide both sides by 3. And I'm going to get y equals minus 1/3 x. Negative 15 divided by 3 is negative 5. So that kind of simplifies that for us. And now we're in that slope intercept form. I picked this problem on purpose because I knew it was going to give me a negative slope. And we want to talk about how to deal with a slope when it's negative. I don't know why I'm making this one so big. So if we look at the equation of this line, the first thing that we know is that at negative 5 on this y-axis, right? Here's our x, here's our y. So at negative 5, we know we're going to have a point on the line, 2, 3, 4, 5. So right here, we have a point on the y-axis. My slope, Valerie, who hasn't looked at the screen in quite a while, is negative 1/3, right? My m equals negative 1/3. When we are graphing a negative slope, it doesn't matter if I graph it as negative 1 over positive 3 or positive 1 over negative 3. Both are true, but I can only do one or the other. I can't make both of them negative, right? Excuse me. What I mean by that is, okay, if I have negative 1/3 and I'm using this one, that would mean I'm going to go down 1 and positive 3. And I would have a point right about here. If I'm doing this one, I would go up 1 and then over negative 3. And if you notice, both those points land on the same line. Either one of these is okay. I just can't make both the 1 and the 3 positive in the same one. Does that make sense? Because if I did it as negative 1 and negative 3, that makes my slope positive, right? It makes it start going up instead of down. So we have to remember that you've either got to do negative 1 over positive 3 or 1 over negative 3. Doesn't matter which one you use, as long as you only put that negative on either the numerator or the denominator. That's where I see most people make mistakes in these kind of graphs is when they're trying to apply a negative slope and they don't know where to put the negative, which one to count negative. Excuse me. I don't want to do any more of those just yet because I want to talk to you guys about parallel and perpendicular lines really quick, and then X and Y intercepts. I feel like I'm going really fast, but I also know that you guys know how to do putting things into slope intercept form because we've already worked on it. Today, really, I just want to focus on the graphing of it. Um, you're going to have some questions regarding parallel and perpendicular lines, and I'm not going to really go into it much because I know I have gone over it with you guys before. But if you remember, parallel lines have equal slopes. You will know a parallel line because their slopes are equal to each other. So if I have one equation of a line with a 2 for a slope and another equation of a line with a 2 for a slope, they will be the same. Right? They will be parallel. Perpendicular lines. Does anyone remember the slopes of a perpendicular line? Wasn't that long ago that we did this? Opposite sign, yes, and then reciprocal, right? They have opposite reciprocal slopes, which means reciprocal slopes. So if I had an M of 3, right, a slope of 3, the slope of a perpendicular line, a perpendicular slope, would be negative, right? Because this one's positive, so it would be negative, and it would be 1 over 3. If I have a slope of negative 2/3, its perpendicular slope would be positive 3 over 2. And the only thing you're going to see of that is they're going to give you like 2 lines and you're going to have to put them in slope intercept form and figure out if they are parallel, perpendicular, or neither. Look out for where they trick you because a lot of times they'll give you that reciprocal, but they won't change the sign. That's where they try and trick you. All right. So just pay attention. That's all you have to do when it asks you if they're parallel, perpendicular, or neither. Write into slope intercept form. Write into slope intercept form, and then look at the slope. Right? And what's the slope? It's whatever's in front of that X. Right? And that's all you have to do. If you write them in slope intercept form, all you have to do is look at the slopes and you can tell whether they're parallel, perpendicular, or neither. The last thing I want to talk to you about is X and Y intercepts because you can use those to graph as well. And then we will be done. We have gone over X and Y intercepts and how to find them. But if you remember, an X intercept is a point on the X axis. And to find them, you just set Y equal to 0 and solve for X. Right? And to find your Y intercept, you set X equal to 0 and solve for Y. Right? And that will find you, that'll give you the point on either axis. So if I have Y equals 5x minus 1, and I asked you to graph this, graph using intercepts. I would find my x-intercept first, right? And all I have to do is go 5x minus 1. Well, it equals y, but we're going to set y equal to 0. And then we're going to solve it for x. So I'm going to add 1 to both sides, and I get 5x equals 1. Then I'm going to divide by 5, and I will get x equals 1/5. So it's not a nice round number, but we know that that point on the x-axis is at 1/5. Our y-intercept for the same equation, 5x, well, it says for the y-intercept, we're going to set x equal to 0, right? And solve for y. So we're going to go 5 times 0 minus 1 equals y, right? Well, 5 times 0 is just 0. And so we're going to get that y equals -1, which means when we go to graph this, all I need are those 2 points that I just found, right? I have my x and my y, and I go 1, 2, 3, 4. 1, 2, 3, 4. Right, I'm drawing all these points. We know that our x-intercept is at 1/5, so not even like barely away from there, right? And we know that our y-intercept is at y equals -1. And those are my 2 points, and I can just connect those 2 points. All right, so we can use our intercepts as well. And you're going to have to, on a couple of the problems, use the intercepts to graph. On most of your problems, you'll be using slope-intercept form to graph. It is a worksheet. Show your work on it when you need to. Like if you have to solve out the problems, do that. But really what we're focusing on are the graphs, right? It's just getting you guys used to graphing stuff. And then next week when we come back, we're going to start talking about like graphs of parent functions and kind of how they move when we graph them. But I wanted to start you off on like some easier graphs before we got into the more complicated graphs. Well, this isn't a slope of 1/5. This is just x equals 1/5, right? So we're just putting the point at about 1/5, right? If this here is 1, I moved it to about 1/5 of 1. Does that make sense? Did you kind of see that? Okay. Now, on your worksheet, I don't know if I have any of the worksheets here. I don't have any of the worksheets here. I wish I did. I think I left them in my other classroom, which is not particularly handy. Oh, they're right here. So the worksheet that you're going to get, I don't know if you can see this. Maybe I'll stop sharing, but your graphs will already be in there. You do not have to be perfect with them, right? You just want a general graph. What am I going to look at when I grade them? I'm going to look at the direction, right? Are you getting your slopes right? If it's a negative slope, is it going down? If it's a positive slope, is it going up from left to right? And I want to see if you can like how you're doing with those intercepts and stuff like that. This is one of your bigger assignments because it's got 18 problems on it, and I'm not shortening it up for you. So, but it's your only assignment you have to do all week, right? And if you need help on it, on Thursday, I will have the meet open the entire time for help with absolutely anything, right? So if you need some tutoring on any of the homeworks at all, please come in and ask those questions on Thursday. Okay? But no other new work this week. Any questions for me before I let you go? I'm sorry it was felt like a long lesson today. Cool, David. So will I.